Hi, my name is Martin, and in this video I will show you how to define custom axis mappings for the Elite Serial plugin. The Elite Serial plugin allows to use old Elite flight training hardware with serial port in X-Plane 11. You can find more information in the description below and also in the introduction video on my channel. Let's get started. With version 2 of the plugin you can find the new menu Axis. It lists all the axes that have been detected with its corresponding data ref. I will choose the pitch and roll axis, and as you can see a window comes up. If you open more than one window, make sure you move them apart to see them both at the same time. On this window you can see the value calculated for the data ref on the left side and raw data from the Elite hardware on the bottom. Currently the yoke is centered, so we have these values here approximately in the middle. I will perform now a calibration and we can see what happens in the plugin. The lowest and highest input values are mapped to -1 and 1, and everything in between the center is interpolated. You see that the input range has a total of 128 steps. My old joystick can actually only stretch to 117 steps, and this results in a steeper line and therefore more sensitive response, as you can see here. I do now the same for the pitch axis. With this completed, we can travel the yoke in all directions and see the response in the axis window and the virtual yoke in the cockpit. So what is this all about? With a standard USB joystick, X-Plane is directly processing the inputs and steering the control surfaces and levers in the simulator. Unfortunately, it's not possible for a plugin to interact with this joystick system. Instead, the plugin can modify the data refs. Data refs are a registry in X-Plane where all simulator parameters can be read and many can be written to. With this, it's possible to manipulate the control surfaces and levers. If you open an action files of the plugin, you can actually see the data refs that are linked to the different Elite axes. You can also see the value range which is fed into the data ref. Now, joysticks are not perfect devices, and the orientation values they provide may not be as smooth or linear as you might hope. In the joystick menu of X-Plane, you have the possibility to adjust the response curve in fine detail. With custom axis mappings, it's now also possible with the Elite plugin to have such response curves. The game port, and to my knowledge also the old Elite devices, use potentiometers to determine the location of the stick or lever, and they tend to be not very linear and may get worse, especially with the age these devices have. I will show you now how you can create a custom response curves that fits exactly to your device. Let's open the Excel sheet that is provided in the Elite Serial plugin folder. The sheet has several tabs with different example mappings. That's because different data refs have different value ranges. I choose the yoke mapping. You can see the response curve on the graph. As in the axis window of the plugin, the input is on the horizontal and the data ref output on the vertical axis. The range goes from -1 to 1 and 0 means the yoke is centered. Column A contains the input values. They go from 0 to 127, and column B contains the corresponding data ref values. You can manipulate the curve by either manually entering values in column B, or better use a formula to derive it from the input value. The template uses a power function which is normalized to 1. Inputs below 8 and above 218 are kept. This is just to accommodate a wider range of devices that might not use the full input range. When using these custom mappings, the calibration function in the plugin is disabled. That's why you should adjust the curve to fit the input values that you read in the axis window of the plugin. Otherwise you might not get a full travel. We now need to copy the values of column B into a separate text file. The easiest way is just by copy and pasting, as I do now. Now we have to tell the plugin to use the text file we just created. We save this text file into the plugin folder. Let's call it mapping_role text. Now we open Actions Default, which is the default configuration file for all mappings in the plugin. Towards the end of the file is the definition of the yokes role axis. To use the axis mapping we created, we need to specify the file name with an @ That's done, so we are ready to go back to Explain. Let's reload the configuration and look at the role axis. Here is the transfer curve as we have seen in the Excel sheet. The yoke is ready to use without further calibration and reacts to the curve. I have now final control around the center, while at the full extension it has become more sensitive. This concludes my short video about custom axis mappings. I hope it was clear and it helps you to get started defining your own response curves. If you have comments, further questions or a suggestion for an audio video about the plugin, feel free to comment below or in the Explain forum. Time to go flying. Thanks for watching.